See, irrespective of the slits, the fundamentals are still the same. That is the reason why I started discussing first this question. It's a three slit. Read the question carefully. In the figure shown, A, B, and C are three slits, each of them individually producing the same intensity I naught at P naught when they are illuminated by a parallel beam of light whose wavelength is lambda, and one information is also given to you. This is the information. Which of the following are correct? Forget about C for a while. Now you see only B, A, right? And take this line as the reference. And take this line as the screen. Here is your point P naught. See, as per my understanding, this is theta. If I are assuming these are double slit situations, here BP naught minus AP naught, usually you will say here it is a 2D actually. You will write this as a 2D sine theta. When angle is small, you know this distance is D. You can almost write it as D by capital T. But they have given BP naught minus AP naught as a lambda by 2. So therefore, lambda is 4D square by capital T. That is one information I have. So when A is correct, B is wrong. The next point is, the next important point what you need to notice is, you need to find the resultant intensity at P. Now, similarly, you will take this line as the reference now. Now, you take A as the standards of the reference. Now, you need to find CP naught minus AP naught. In my view, this is again a double slit with a 3D distance. Right. And the, right, I'll write somewhere over here so that there is no confusion here. Let this be C. Let this be A. This is the situation. Exactly here you have the center of the screen. Some theta. Theta. Now you try to please understand, this is a 3D. This distance is 3D. And one more important point is, at this point, otherwise I would have written CP naught minus AP naught as 3D sine theta. By the way, this distance is a 3D by 2 now. So therefore, 3D times theta, 3D by 2 by capital T. Remember, when angle is small, sine theta can be written as a tan theta also. But remember, this is only when angle is small. Now, this will become 9D square by 2D. Right. And yeah, individually producing the same intensity I naught at P naught when they are illuminated by parallel beam of light. Now see, try to please understand. 1 minute. I need to convert this into my known format. If I see 4d square by r, wherever I see d square by capital D, now I can write lambda by 4. This is 9 by 2 times lambda by 4. This is 9 lambda by 8. Or in other words, you can write it as a lambda plus lambda by 8. Hold on. Remember, if I take A as the standard reference, okay, A as the standard reference, I know BP naught minus AP naught is, that is path difference, is given in the question, lambda by 2. Similarly, now I have obtained one relation, CP naught minus AP naught is lambda plus lambda by 8. For example, if I take at A the phasor as the reference, so BP naught phasor lambda by 2 is nothing but 180 degrees. If I take this as AP naught with respect to AP naught, BP naught lambda by 2 means pi, 180 degrees. Now again you do the difference between, let this be equation 1 and let this be equation 2, for example. CP naught minus BP naught is equal to 2 minus 1. You'll get lambda by 2 plus lambda by 2 plus lambda by 8. This minus this. This can be written as 5 lambda by 8. 5 lambda by 8. 4 lambda by 2, 5 lambda by 8. See, corresponding phase difference is what I want. Lambda implies 2 pi. Now tell me what is 5 lambda by 8. This is the equivalent phase is 5 by 8 times 2 pi. 4. 5 pi by 4 RAR. It is 5 pi by 4 means literally this is nothing but pi plus pi by 4, which means now I am writing about CP naught. CP naught reference is this one. This is the line. CP naught reference is this line. With respect to this line, you require 180 plus pi by 4, which means you'll get another phasor here, pi by 4. Remember, this and this will get cancelled. You will have only one. So therefore, the resultant intensity at P naught when all the 3 slits are open, you will get only intensity due to one light, because these two phasors gets cancelled. So therefore, the resultant intensity at P naught will be only I naught. Now, I want a confirmation from your side. Anyone try to please respond and say yes to me. Because unless or until you don't confirm me, I cannot come to a conclusion that you have followed this. No one? How do I know whether you followed it or not? Oh, God. Right. Okay, chalo. I assume that you have followed. Right. This is about three slits. So when you are given three slit problem, first you take one as a reference. Say, for example, AP not as the reference. Then what you need to do is gradually you pick BP naught, you pick CP naught in terms of lambda or phase, whatever it is possible, it is up to your choice. Thereafter, what will happen? You know, thereafter, you will get a conclusion about the phase angles of these three sources. Only then I have concluded about the final intensity part. Even next time, I'm going to give you 4 slits. In this part also, you are going to do the same actually. But read the question carefully. Read the question carefully. Right. You have an arrangement, interference arrangement. Shown has 4 sources, S1, S2, S3, S4. Wavelength lambda. Lambda is equal to 400 nanometer. S1, S2, S4 are in phase. S1, S2, S4 are in phase, while S3 is out of phase. Right. Means by default, the starting itself, they bear a phase difference of what do you call pi. Separation between any of the two slits is 1 mm. Distance between the slits and the screen D 10. So this is the case where D very, very small when compared to capital D. Right. Distance between the right point O on the screen lies on the perpendicular bisector of S1, S2. Point B is the point on the screen close to O, which has an intensity 2I naught. When only S1 and S2 are switched on. This is one important data. After all the switches are switched on, which of the following options is or correct? Hold on. Forget about the entire question. You choose only S1 and S2. You choose S1 and S2. Now, try to please understand. These are your slits. I am not at all touching the other parts. Here is your screen. Here is some point P. I am assuming that this has some theta. S1, S2 are in phase. Right. What you want is S2P minus S1P. This is some path difference delta X. You can call it as d sin theta also, no issues. Suppose you know the expression. What is the expression? If they bear a phase difference of, say, for example, some delta phi, then at point P, intensity is given as 4I naught cos square delta phi by 2. 4I naught cos square delta phi is equal to 2 pi by lambda times delta x. Right. So keep that in your mind. Delta phi by 2. Right. See, remember they have given this part as 2I naught. 2I naught. Which clearly implies cos square delta phi by 2 is 1 by 2. Implies delta phi by 2, 1 by plus or minus 1 by root 2 actually. So it can be 45 degrees or 135 degrees, which clearly implies the phase difference is 90 degrees or 270 degrees. So the path difference lambda by 4 or 3 lambda by 4. Right. This is one important observation. Right. Now please try to understand lambda by 4. Now, by the way, we will connect this relation again here. D sin theta is path difference lambda by 4 or 3 lambda by 4. Right. Lambda by 4 or 3 3 lambda by 4. For any of these things, okay, you take a minimum, for example, right? So D times D by capital D is lambda by 4 or 3 lambda by 4. So wherever I see 4D square by capital D, I will use a lambda or 3 lambda. Let us see what happens in the process. Right. Now we will, how the way I have done the previous question, we will work in the same way. Now S1, S2, you have a clear idea. Let us take S1, S3. S1, S3. S1, S3. So therefore, S1, S3, and here is our point P. And this distance is 2D. Now S3P minus S1P is, I mentioned this is a 2D path difference. And this can be written as a 2D sin theta. Right, 2D sin theta. Here, D sin theta I have already. So S3P minus S1P is either lambda by 2 or 3 lambda by 2. The problem is already S3P is out of phase difference by default in the production stage itself. So S3P dash plus lambda by 2 minus S1P, because it's already, as they mentioned, out of phase, means path difference at any point equidistant is still lambda by 2 by the production stage itself. Lambda by 2 or 3 lambda by 2. So therefore, effective S3P dash minus S1P can be written as 0 or lambda, but they meet constructively, that's for sure. My goodness, I have done 50% of the problem. Yeah, we require one more point. Same S4P, S4P. S4P. Anyone trying to interact with me, please do that. No issues. Anyone trying to interact with me, please do that. S4P minus S1P is, again, we need to find the basic D. It's totally 3D. You'll write this as simply some 3D sin theta. No, yeah, I got a point. You wish You should to express the location actually. 1 minute. You wish to express the location, got the point. So actually, with respect to this point, angle is given. I got the point. Someone was trying to interact with me, got the point. 1 minute. Just give me some time. You got your point. The point P is still the same. Right. Now the question is the angle part. Now, with respect to S1, this part is very clear. Will this help me in locating P from O? Let me try to see. Yes, that will help me. I'll assume one out of this for a while. I'll assume one out of this. In this case, let us take sine theta as lambda by 4D and sine theta, some y I'm assuming here from O, it is y by capital D is lambda by 40. Y is lambda capital D by 40. That's the fact. That is the location of the y. First, that is important. Now, with respect to this point, see, when you are taking S1, S3, this is the midpoint. And this is D by 2 already. And this is Y. So therefore, when I am taking S3P, here, S3P minus S1P, I am not considering the phase at this point right now. This is equal to D sine theta 1, some different angle. Actually, 2D sine theta 1. 2D sine theta 1 can be written as, yes, now you know the idea, no? Y plus D by 2. This is Y plus D by 2. As a result, what you will have is Y plus D by 2 by capital D. This you will write it as 2D by capital D times Y plus D square by capital D. Right. Hold on. No issues. And previously also, right. This is Y I'm substituting 2D by capital D times lambda capital D by 4 small d plus D square by capital D. Yeah, D cancel, capital D cancel. Capital D. But now you bring your picture here. It is actually S3P dash plus lambda by 2 minus S1P. So cancel. So clearly it is S3P dash minus S1P is D square by capital T. Remember, at a later stage, I got now from this, I got right path difference. Path difference. You got sine theta as lambda by 4. Now you take again this part. S2P minus S1P is according to you D sine theta, means Y by capital D. And this is nothing but lambda by 4. Right. So S2P minus S1P is lambda by 4. S3P dash minus S1P. Now, similarly, I will make one more arrangement. I'll make one more arrangement, S4P minus S1P. I got some messages. Out of phase means, I'll explain. For example, you have S2, you have S1, you have point P. See, if they are in same phase, S2P is same as S1. If they are different phase, you should not write it as S2P. You should write it as S2P dash plus or minus lambda by 2. Out of phase means exactly opposite. 180 degrees phase difference. 180 degrees phase difference means you will write it as lambda by 2. I think I'm very clear on this. Can you please confirm this first? Someone? I am seeing the messages. Can you please confirm this? Right. Thank you. You don't confirm me. My problem is I'll be not in a state to confirm to go further or stay there only. That's the problem. Right. 1 minute. So now, on this basis, I have derived the situation like this. I think they have given some values also, actually. I need to see that part also. They have given some values. They have given some values. They have given values like this. Hold on. A d square. Can you please help me in writing d square? D square is 1 mm square, 10 power minus 6 meter. By capital D. What is capital D? 10 meter. By this will be 10 power minus 7 meter. Means 10 power minus 7. Wavelength is given as nanometer, 400 nanometer. This is 100 nanometer, which means 1/4 of the wavelength. This is the crucial step. S2P minus S1P is also lambda by 4. S3P dash minus S1P is also lambda by 4. Right. So they will add together. By now you need to work on 3D sine theta. Please try to understand what is the midpoint for this gap 1 somewhere here. Somewhere here is the midpoint. You know, this will be d by 2 again. Santosh. Hello. Santosh. అరే బాబు నువ్వు బుద్ధని చెప్పిన సెంట్రల్ ఆఫీసులో ఉండి ఆన్లైన్లో క్లాస్ చెప్తున్నా. ఓకే. ఒక 2 hours అయితే క్లాస్ ఫ్రీ అయిపోతాను. రైట్. రైట్. And this is 3D via sin theta means this angle. Very clear. D plus y by capital D. This is 3D square by capital D plus 3dy by capital D. Yeah, no, already you know what is y. What is y, you know already. That we will substitute here. 3D square by capital D plus 3D by capital D times y. Y means lambda capital D by 4D. lambda capital D by 4D. DD cancel. This is cancelled. Just now we have seen, hold on. Just now we have seen D square by capital D is lambda by 4. So 3 lambda by 4 plus 3 lambda by 4 is 3 times lambda by 2. Which means lambda plus lambda by 2. I got a very clear clarity now. Now I am drawing phasor angles. So now S1P is taken as a phasor like this. With respect to S1P, S2P is lambda by 4, means 90 degrees. 90 degrees. With respect to S2P, this one. With respect to S1P, S3P is lambda by 4, which means again the same. Another, suppose if this is A amplitude, this is A, this is A. Next, last but not the least, somewhere we have done 3 lambda by 2. You know what is 3 lambda by 2? Lambda plus lambda by 2 means exactly opposite direction. You know, with respect to S1P, S3P, I repeat each and every case. S1P, with respect to S1P, S2P is 90 degrees, S3P is 90 degrees, S4P is 3 lambda by 2. Means lambda plus lambda by 2. Lambda ke 360 degrees 3%. Malli plus lambda by 2, 180 degrees. ఈ రెండు cancel. ఈ రెండు యాడ్ అప్ అయిపోయి you will get 2A resultant amplitude. Intensity 4A square, 4I naught. So C is correct. Sorry, B is correct. C is correct. Actually, D correct కాదు. D correct కాదు. Right. So this is the way how you need to solve 4 slits. Remember, I am teaching you again. You take step 1 as reference with respect to one of the, better you do lowest slit. Followed by taking the lowest slit as a standard reference. You take S1 as the lowest slit. S1P, you take it as standards of reference. Followed by S2P minus S1P, followed by S3P minus S1P, followed by S4P minus S1P, and draw phasors. Phasors gives you the picture. Right. Now just please give me confirmation about this. Have you followed or not? Confirmation is required. Some students might feel, "Arey, itna lengthy." Yes, who asked you to do? When you have fundamental, you are not preparing for 60 out of 60. Yes, it is a difficult topic. Only toppers will do such questions. No, always in phasor diagram, you should take amplitude only. If you take intensity, you may get answer as 2I naught, which is wrong. In phasor, you should take amplitude only. I think same thing I have done in this question also. Same thing. Fortunately, in this question, it is only amplitude. Single one survived. You got I naught. Okay. But trust me, the answer for this is definitely C. Right. Anything else? Question me now. Phasor diagram, you should always take amplitude term only. So I have solved your 3 slit question, 4 slit question at a time. Are we clear? Give me confirmation that have you understood this or not. You should confirm, otherwise how do I know? I'm still unable to see a message from your side. Yes, sir. Thank you. Now we'll proceed further. Now you try to see this question. I'll do one after the other all. I have selected only 4 questions for today. Why don't you try this? Try this, everyone. I hope you are working on this. Right. I'll take up this now. Fifth question. You see, ABC is a spherical wavefront whose center is at. They are, in fact, so how come such situations happen? That I'll try to explain. So far, what are the situations that you are facing is you have S1, you have S2, that's the plane wavefront. This is the plane wavefront, which means the wavefronts will be like this. This is how you'll have plane wavefronts. Now you take a different case now. Suppose if the source, if the source is a virtual source, for example, then light they'll extend like this and they might here. In this case, wavefronts will be like this. Whatever it is, remember these slits are on one single wavefront. Whatever it is, still it is ydse exam. Therefore, this is the case which they are discussing about. Now you take ABC as a spherical wavefront centered at A, symmetric about BE, S1 and S2. BS1, 3 lambda. S1, S2 is 4 lambda. They are given S1, S2 as 4 lambda. BS1 is a 3 lambda. BO is 6 lambda. It means 3 lambda this side, 3 lambda this side. Right, no issues. S1E is 128 lambda. Lambda refers to wavelength. Good, very good question. A mica sheet of refractive index 1.52 is pasted on S2. That will introduce some path difference. Sheet for which central maximum don't form at E is R. Hold on. So what situation you are expected to work on here is a very simple thing. First is a normal, right? AO. OA, I know now. OA and OB are same. Normally, physically. That is the radius of curvature. And that is 6 lambda. Right. Now you are covering this portion with some mica sheet. Right. And one more important point, SO is 5 lambda actually. Normally, S2O is 5 lambda. S1O is 3 lambda. That is given actually. S1O is S1, S2, 4 lambda. So S1O will be 3 lambda. Right. And one more important point, this is 128 lambda. Now, try to please understand. What condition you want? S2E is a, if there is no mica sheet, S2E minus S1E is your discussion. S2E minus S1E, if there is no mica sheet, I'm speaking about, is not equal to S2E. Now you write S2E in this plus mu minus 1 into T, minus 1 into T. S2E contains mu T medium part. Therefore, mu T minus T you need to do is equal to S1E. So therefore, S2E is, this is 3 lambda. This is also 3 lambda. This is 4 lambda given. Now we will work on first not central maximum. I'll just go differently. You want constructive condition. What is the constructive condition? That we will work. Some integer multiple of lambda. That we will work. 3 lambda. 5 lambda. Basically, S2, S1 has a difference of how much? S2O, S1O will have a maximum difference of 2 lambda actually. This 2 lambda path difference, I'll write it elaborately here so that there is no confusion for you. I want a bigger diagram. Almost I have cracked the question. I just want to draw the diagram in a bigger way. Please allow me. Right. Thank God. Frankly speaking, when a wavefront reaches S2, no, we'll try to please understand these two, S1, the problem here is S1 and S2 are not on same wavefront. That is the first observation. Why? I'll explain this. We know S2O is 5 lambda. S1O is 3 lambda. Now tell me how come they lie in the same wavefront? So basically, the generation process itself, in the absence of mica sheet, in generation itself, they bear a path difference of how much? 2 lambda. Now I am working on S2E minus S1E. If equal to an integer multiple of lambda, E becomes maxima. Remember, S2E is covered. So geometry S2E. Now, you know, when you are doing Young's double slit experiment, if upper slit is S1, lower slit is S2, then when mica sheet is covered, what is that you have done? Tell me here. That is the basic here required. That is the basic required here. What is that you are doing is it's shifting up. Central max shifted up. Why I will explain. See, if this is P, S1P, okay, minus mu minus 1 into T must be same as S2P. S1P plus mu minus 1 into T is the same as S2P. This is the condition which you want. Regular ydse experiment. So in that case, what you are doing is obviously working like this. The same situation I am facing it right now here. Because in S2P part, T thickness, it is working in air. So therefore, S2P plus S2P plus S2P is up, right? S2P minus actually. Minus mu minus 1 into T minus S1E is equal to n lambda. That is the condition. Right. The geometry part, if you take, this is 2D. And this is some theta. The geometry part as S2E. Someone asked me S2E minus S1E geometry wise. I would have written this simply as they are separated by a distance of 4 lambda. So D is 4 lambda here. D sin theta kada. So 4 lambda times, okay, 2 lambda by, what is this distance? That distance is 128 lambda. Right. 128. Cancel. 8 lambda by 128. Maybe one time 48 lambda by 60. So come back to here. So therefore, lambda by 16. And by the way, the generation itself, they bear some path difference. They bear some path difference. That path difference is 2 lambda. So effectively, it is going to be minus lambda by 16 plus 2 lambda is mu minus 1 into t. I am taking n is equal to 0 as a condition, minimum. Or you keep that only, you try different options. By the way, what do you want? Thickness of the mica sheet. Mu is given 1.5. So 2 lambda minus lambda by 16 is 1 by 2 times t. This is the case where n is taken as 0. Here 2 lambda minus lambda. 31 by 8 lambda is one option. Let me see if it is 31 by 8 lambda for this central maxima form at E, which means this is not possible, this is not possible, this is not possible. They want not possible cases. That's it. BCD. Right. Yes. Any doubts on this? Please tell me. See, I have clearly given a detailed analysis of this question. Right. But still, it is open to you. Yes, confirm whether you understood this or not. Want an answer from your side. Almost 1.5 hours. Right. Tell me, are we clear? Message me. Right. Very good question. అలా కాదమ్మా, ఇప్పుడు ఇయర్లో మామూలు పాత డిఫరెన్స్ అయితే లాంబ్డా బై 16. ఓకే. ఇప్పుడు మైనస్ లాంబ్డా బై వెరీ గుడ్ క్వశ్చన్. ఎందుకు అట్ట రాశారు అంటే, ఎప్పుడైనా చూడండి, దీనికి కిందకు వస్తే మైనసే, అబౌవ్ వస్తే ప్లస్. ఈ లైన్కి కిందకు వస్తే వై కోఆర్డినేట్ నెగిటివ్, ఈ లైన్ పైకి వస్తే వై కోఆర్డినేట్ పాజిటివ్. అందుకే మైనస్ లాంబ్డా బై 16 తీసుకుంటాం. నాకు నచ్చదు, ఓకే, అప్పుడు ఏం చేయాల్సి వస్తుంది? దాన్ని లాంబ్డా బై 16 మైనస్ 2 లాంబ్డా చేయాల్సి వస్తుంది. ఇబ్బంది పడతారు జామెట్రీలో. బిలో లైన్ వస్తేనేమో ఒకలా తీసుకోవాలి, అబౌవ్ వస్తే ఒకలా తీసుకోవాలి. రైట్. క్లియర్? మెసేజ్ బాయ్స్, మెసేజ్. Right. Okay, I'll close the class and I'll post you the notes also.